Hey guys, so as promised, here's the video on the couple of examples that I didn't get to go over in class today. So we talked about probability for the first time today, and I said there's lots of examples to look at. And example 3 and example 4, we didn't get a chance to go over in class, but I really need to make sure you guys know how to do those problems. So let's go over them. All right, so in this example, it says we're going to flip a single coin 3 times or flip 3 coins all at the same time. And it's going to ask us to find a bunch of stuff, and the first stuff that we're going to find is the sample space, S, and the probability of S, and the probability of the empty set. Okay, before we get to finding it, I need to talk about this experiment a little bit. The most important thing in any probability problem is for you to read it carefully and know two things. Make sure you know absolutely clearly what the experiment is and what the outcomes look like. So again, it says we're flipping a single coin 3 times. So this is the experiment. Flip a single coin 3 times. We'll talk about the one in parentheses in a second. So when I ask students in class, okay, the experiment is you flip a coin 3 times, someone give me an example of one outcome of this experiment. So a lot of times students will just say heads. But please understand, heads is not an outcome of this experiment. What you need to think about is you need to finish the experiment once in order to get one outcome. In other words, you have to do this whole thing that's boxed before you get one outcome. If the example was flip one coin, then yeah, heads could be an outcome or tails can be an outcome. But we're flipping 3 coins. We're flipping a single coin 3 times. So the point is, in order to get one outcome, you have to complete this. You have to flip a single coin 3 times. So I want you to imagine we flipped one coin 3 times, and then you tell me what happened after we flipped it 3 times, and that's one outcome. So instead, an example of an outcome of this would be something like heads, heads, tails, which would mean the first flip was heads, second flip was heads, and the third flip was tails. Okay, so please understand, it looks like I wrote 3 symbols here, which I did, but that's one outcome. So in other words, again, to do this thing, once you do this thing once, you flip a single coin 3 times. If you do that, then this is an example of an outcome you can get. Think about some other outcomes you would get. See if you can come up with another one. Let me go ahead and write some other ones. Here's another example, something like heads, tails, tails. Again, that would mean on the first flip, the coin landed on heads, and on the second flip and the third flip, it landed on tails. So I really want you guys to understand that in this example, one outcome looks like 3 letters. Okay, it takes 3 letters to describe to me the one outcome. Okay, and then I wrote also, or flip 3 coins all at the same time. These 2 experiments, the one that's boxed and the one that's underlined, are almost exactly the same thing. They're not exactly the same thing. For the box situation here, we're flipping 1 coin 3 times, whereas here we're flipping 3 separate coins all at the same time. But if I said, okay, let's say you flip the 3 coins all at the same time, what do you get? Again, the outcomes would look similar to the ones that I have here. For example, let's say your outcome was tails, heads, tails. If you're thinking about it this way, we're flipping only 1 coin, but 3 times. So first flip is tails, second flip is heads, and the third flip was tails. Whereas if instead you imagine you flip 3 coins all at the same time, then this would be what happened on one of the coins, this would be what happened on the second coin, this would be what happened on the third coin. Now, if that gets a little confusing, if you're thinking of 3 coins that are identical, like we're flipping 3 quarters, take 3 quarters and throw them up in the air all at once, that gets a little confusing, you do need to remember that the 3 quarters, even though they look the same because they're all quarters, they are actually different things. Maybe they have different dates on them, things like that. So if that gets confusing at all, maybe it's easier to think of 3 different kinds of coins. So maybe a penny, a dime, and a quarter or something. So then this could be the outcome on the penny, and this could be the outcome on the dime, and this would be the outcome on the quarter. Okay, so when you flip 3 coins all at once and you tell me the outcome, you're going to just always tell me in this order. So penny first, and then tell me what happened to the dime, and tell me what happened to the quarter. Okay, so make sure you're clear again what the experiment is and what the outcomes look like. So remember, let me say it one more time. The outcomes look like 3 symbols. You have to give me 3 symbols to give me one outcome. Okay, because you have to, in order to complete this experiment once, you have to flip a coin 3 times. Flipping a coin 3 times, okay, so this is the most part. It takes 3 flips to complete the experiment once. And then once you flip 3 coins, flip the coin 3 times, you tell me what happened, and the answers are going to look like 3 symbols. So everything I'm circling here, this is one outcome, this is another one outcome. This is also one outcome, made of 3 symbols, but one outcome. Okay, so now that we're clear on that, let's go ahead and find the things that it's asking us to find in this example. So the first thing it's asking you to do is to find S. Now, normally in a problem, I'm not going to tell you what S stands for, but you know what it is because we talked about it in class. S stands for the sample space. So S is a list. So when you go to find S, you're going to put curly brackets and you're going to list all the outcomes of this experiment. So, for example, here's one outcome: heads, 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 heads. That's one outcome. And now we're going to list all of the outcomes. You want to make sure that you list them all. You don't forget any. Let me give you another one: heads, heads, tails. And a couple ways to make sure you get all of the outcomes. One way is to do it in an organized way. Don't just sit there randomly think of outcomes, because then you're going to look and go, which one did I miss? And it might take you quite a while to figure out which one you missed. Another way is to use some counting techniques, which we're going to talk in class soon. And the counting techniques will tell you how many outcomes there are, and then you'll know if you have if you have the right amount of outcomes, then you know you have them all. For example, I know there's supposed to be 8 outcomes in this experiment, even though I know we haven't talked about it in class yet. All right, so I'm going to go ahead and write down the other ones. So heads, tails, heads, heads, tails, tails. What I've done there, that's basically all the possible outcomes that start with the symbol H, which start with heads. So then now I can easily get the rest. I ran out of room and go to the next line here by just writing all the same things, but make the first symbol tails. So this is all the outcomes where the first symbol is tails. So tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Okay, so you list all the different outcomes, and that's what the sample space is. Okay, and the rest of it shouldn't be such a big deal. Probability of S. Okay, the probability of the sample space is always 1, no matter what. So there's really no work to show. Just write 1 for the probability of the sample space. And then when you're trying to find the probability of the empty set, that's another one where it's very easy. You just have to write down the answer. The probability of the empty set is always 0. Okay, so just write 0. Probability of the empty set is 0, and that's the end of the story there. No work. You don't have to show work for probability of the empty set or probability of the sample space. But I do want you to be careful. Keep in mind that the stuff that's in the parentheses is a list or an event. So we have an event here, but the answer to the probability is a number. Same thing here, we have an event here. This is a list. This is an empty list. Don't think of this as 0. That's an empty list. But the answer is 0 because the probability has to be a number. Okay, so now we're going to define some other events on this experiment and then find their probabilities. Okay, so now we're looking at the event where the first and third coin land on the same thing. So we understand what that means. It means whatever the first coin lands on, if it lands on heads, then the third coin would also need to land on heads. And so the question says to find A, which is an event, it's a list, and then find the probability of A, which is a number. So let's go ahead and start with A. So since it's a list, you're going to put curly brackets, and then you have to list all the outcomes where the first and third flip are the same thing. So here's an example: heads, heads, heads. That's definitely an outcome of this experiment. And look, the first and third coin land on the same thing. Are there any other outcomes where the first and third coin land on the same thing? Well, we can try heads, tails, heads. Notice this description for A that's over here doesn't mention anything about the second flip. So the second flip can be anything as long as the first and third flip match. It's fine. So first and third match here. So that's another outcome. Okay, what other outcomes do we have in this experiment? Well, the two that are already there are the only ones, it seems, where the first and third coin land on heads. So it looks like what's left is all the outcomes where the first and third coin land on tails. So for example, we have tails, heads, tails. Again, those two are the same. And what else, guys? Sorry, it's looking a little sloppy here. And then the last one, tails, tails, tails. Again, the first and third match. So there's event A right there. All right, let me go ahead and get rid of these arrows to just clean it up a little bit. Now that we have A, how do we find the probability of A? Well, we have a formula for it, the classical formula. The formula for probability of A is absolute value of A over absolute value of S. Absolute value of A is the number of things in A. If you count the number of things in A, it looks like there's 4 things. 4 different outcomes in this event here. And then how many things are in the sample space total? You have to go back to the previous slide to see that, but there's 8. So in this experiment, there's 8 things in the sample space. For all the problems I do, it's going to be 8 things. Okay, so if the problem asks you to find the event A, you make this list, and here's the answer. And if it asks you to find the probability, then the answer is 4/8. All right, let's do another one. Okay, so another event. This time it says all the coins land on the same thing. So that's what B is. And the question, again, is asking us to find 2 things. B, which is an event, and then probability of B, which is a number. So this is a list we're going to find, and this is a number that we're looking for. Okay. So to find B, it's a list. So curly brackets. And let's see. Think of all the outcomes of this experiment. Don't forget, we're flipping 3 times. All the outcomes where all the coins land on the same thing. Well, heads, 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 they all landed on the same thing. In other words, all 3 coins landed on the same thing. Or if we're just flipping a coin 3 times, all 3 flips landed on the same thing. What else? Yep, I'm sure you guessed it. Tails, tails, tails is the only other one. Okay, and then to find the probability of B, same formula. Absolute value of B over absolute value of S. Absolute value of B is the number of things in B. How many things are in the event B? How many outcomes? 2 outcomes. How many outcomes in S? 8. And that's the answer to that. So here's the answer for finding event B, and here's the answer for probability of B. Okay, let's try another one. So now we have this event C. It says the second coin lands on tails. And again, they're asking us to find C, the event, and then its probability. So for C, I'm going to put curly brackets. You have to list all the outcomes where the second flip is tails. So it doesn't mention anything about the first flip. So the first flip can be anything. So one way to do it is to try to figure it out without looking at the sample space. Or another thing you could do is you can go ahead and look at the sample space and scan it and see if there's any outcomes where the second coin lands on tails and put them all in here. I'm going to try to do it without looking at the sample space, but if you need to go back and look, go ahead. So the second coin has to land on tails. The other coins can be anything. So heads, tails, heads. The second coin landed on tails there. Heads, tails, tails. Second coin landed on tails there. Tails, tails, heads. The second coin landed on tails. Tails, tails, tails. The second coin landed on tails. And I think that's it. So that's the event C. And now we're going to find the probability of C. Again, notation. Absolute value of C over absolute value of S. How many things are in C? 4 things. How many things are in S? 8. Okay, so once again, there's the answer for the event. If I ask you to find C, there's the answer. If I ask you to find the probability of C, there's the answer. Okay, we got one more, I think. All right, so this is the last one in example 3. Another event, the event that the results of each flip alternate. So you want to make a list again, okay? So when you're finding D, you're going to make a list of all the outcomes of this experiment where the results alternate. When I say alternate, I mean if one of them's heads, the next one's tails, the next one's heads, the next one's tails, like that. They just keep going back and forth. We're only flipping 3 times though, so let's say the first flip's got to be either heads or tails. If the first flip is heads, then and they alternate, then the second one's tails and the third one's heads. That's one outcome where the results alternate. Well, the only other thing that could happen is that it starts with the tails, and then what is it going to be? Tails, heads, tails. Yeah, so that's it for D. And then the probability of D is, again, absolute value of D over absolute value of S. Number of things in D is 2. Number of things in S, 8. Yeah, so that's how this experiment goes. There's the event, the answer for the event, and there's the answer for the probability. All right, let's go ahead and look at example 4 now. Okay, so this is an important one, so let's make sure we look at this. The question says that we're going to roll a single die twice, or we're going to roll a pair of dice once. So the point is, you're going to roll 2 die, or a pair of dice, and once you've done that, you've completed the experiment once. So for example, if I ask you, give me an outcome of this experiment, if you say 3 is an outcome, 3 is not an outcome. Because if you say 3, that's like the result on 1 die, but in order to do this experiment, you have to roll a die twice, or you have to roll a pair once. So outcomes are going to look like pairs of things. So for example, an outcome of this might be something like 3, 1, like this. So what does this mean here? Again, this is not 2 outcomes, this is 1 outcome, because the experiment says twice. So you're rolling twice, or you're rolling a pair once. So again, what does this mean? If you think of rolling a single die twice, this could be the first roll, and this could be the second roll. Or if you want to think of rolling a pair of dice, then you can think that this is the outcome of one of the dice. So this one here would be the outcome of one of them, and this is what the other one landed on. And if you're like, wait a minute, how can you tell which one's which? Maybe it's a little easier if you think of them as being different colors. If dice have the same color, it's kind of harder to think about because they're both red. It's hard to distinguish between the two, but they are different dice. So maybe it'd be easier if you're rolling a pair of dice to think of this as what the white one landed on, and this is what the red one landed on, for example. Okay, anyway, so make sure you understand what the outcomes of the experiment look like. Once you get that, then the next thing is the notation. So I'm not going to be drawing the dice like this. So what else could we use? Some books use something like this. They'll put like a 3, 1 with a comma and a parentheses, indicating the first die landed on 3 and the second one landed on a 1. Some other books will use things like 3-1. Again, same thing, meaning the first die landed on 3, second die landed on 1. What I'm going to use just 3, 1 like this. I figure people will not get confused. Don't think of this as the number 31. This is the first die landing on 3, second die landing on a 1. Okay, so now that we've established the notation, let's go ahead and find the sample space. Let me go ahead and erase this mess over here. Okay, so when we find the sample space, remember that it's a list. So to find the list, you're going to first put S, and then curly brackets, and I'm going to start listing all the rolls of the dice, all possible pairs of rolls of dice. So, for example, we can write 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. There's more than this, but what I'm writing here is all the rolls where the first roll was a 1. I'm going to try to do it in an organized way. You'll see why in a little bit. So what else is there? All the rolls where the first die landed on a 2. So we're at 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. And we could do this all the way down. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Keep going. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, and on we go. So we're going to do all the ones that start with 5, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and all the ones that start with a 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So this one's rather long to write down the whole sample space, but I wanted to write it down so you could see it. So those are all the outcomes. It turns out there's 36 different outcomes there. You can count them. There's 6 in each row, and there's 6 rows, so that's 36 outcomes there. Okay, so that's the answer for the sample space. Real quick, let me just go ahead and write the answers for the probability of the sample space. So we know the answer already is 1. And the probability of the empty set is 0. Again, that's true for any problem. There's work you could show, but I don't really need it. You could just write that. One other thing I want to mention, though, as far as rolling a pair of dice, like when you play a game like craps, what you care about the most is the total when you roll a pair of dice. So I do want to mention that if you write the sample space exactly the way I wrote it, 6 things per row like that, then all the dice that have a certain total fall in the diagonal. For example, if I want to find all the dice where the total is 5, these are all the dice right here where the total is 5. 1, 4, 2, 3, 3, 2, 4, 1. They all have a total of 5. If I want to find all the dice that have a total of 6, you can just go to the next diagonal. Total 6. These have total 4, total 3, total 2, and like that. So this is all the dice that have total 7, so it's diagonal. The total is 8, total is 9, and you get the picture there. Total 10, total 11, and total 12. That's a nice little thing if you write it. If you write the sample space this way, if you organize it this way. All right, so let's look at some events and find them and find their probabilities. Here we go. Okay, so A says the total of the numbers on the die is 7. Okay, perfect. So again, you can go back to the previous slide and go, let's list all the ones where the total was 7. So one way to do is go to the previous slide. Another way to do it is to see if you can think of them without going back to the previous slide. So I'm going to go ahead and write A here. Total is 7. Well, 1, 6. And then what else? Well, I'm going to change the 1 to a 2. That will make the other one have to be a 5. Then 3, 4, 4, 3, 5, 1, and 6, 2. I'm sorry. What did I do wrong here? Oh. Okay. 5, 2, and 6, 1. Those are all the rolls of a pair of dice where the total is 7. Okay, and then how do you find the probability of this event? Again, we have a formula for it. It's absolute value of A over absolute value of S. Absolute value of A is the number of things in A. You can count and see that there's 6 things there. How many things are in S? We already mentioned there was 36 things. Now, we did look at this one in class. We used the empirical way of calculating the probability that the total is 7. So I just want to tell you what the decimal answer for this is if you put in the calculator. If you put in the calculator and write as a percentage, it's approximately 16.7%. I write it for a few reasons. One, because we saw it in class. Another is because when you play craps, rolling a 7 is kind of an important thing. So you might want to know what the probability is of rolling a 7. Okay, let's go ahead and try another one. Okay, this one says, again, same thing, rolling a pair of dice, or rolling one die twice. And B is the event that the total of the numbers is at least 11. So we have to write down all the outcomes where the total is at least 11. So if you're finding B, you make a list of all the ones where the total is at least 11. Well, the total is 11 if you roll a 5, 6, or a 6, 5. Those are the only ways you can get a total of 11, but it says at least 11. So it means it could be higher. So 11 or higher. So those are 11, and what could be higher? 12, you can get a total of 12. There's only one way to do that, 6, 6. And you can't get any higher than that. Let's make this 6 look a little nicer. Okay. Yeah, so that is event B. And then to find the probability of B, again, we're going to use the formula. It's absolute value of B over absolute value of S. How many things in B? 3 things. How many things in S? 36 things. Okay, that's the answer to that one. Let's go to the next one. Okay, so another event. The total of the numbers on the die is at most 4. At most means 4 or less. So we have to write down all the outcomes where the total is 4 or less. Okay, total 4. Here's one way. Here's another way. And here's another way. And I think these are all the ways where the total is 4. How about total less than 4, like 3? If the total is 3, here's a way where the total is 3. Here's another way where the total is 3. Those are the only ways the total is 3. How about total 2? Like this. And you can't have a total less than 2, so that's it. So that's the answer, but let me make sure you guys have this organized. So here the total is 4. Here the total is 3. Those are all the ways the total is 3. And there's all the ways the total is 2. Okay, so at most 4 means the total is 4 or less. So 4 or 3 or 2. Okay, so that's C. Once again, let's find the probability of C. Formula is absolute value of C over absolute value of S. How many things are in C? Look up there, it looks like there's 6 things. 36 total. And that's the answer to that probability. Alright, hope you guys are getting the hang of this by now. I'm sure you are. Let's go ahead and knock out the rest of them. Let's look at D. Okay, now I worded this one like this so I can be clear, but it may start to get unclear. Let's see what it says. So D is the event that the absolute value of the difference of the numbers on the die is 2. All I'm trying to say here is the difference, the two numbers on the die are 2 apart. The difference between the numbers is 2. But then some mathematician may come along and say, well, what if the difference is -2? What if you switch the order? So that's why I put absolute value, meaning the difference is 2, and I don't care which one's higher, which one's smaller. So before I go ahead and find the whole answer, if you roll something like a 3-5, we're going to say that difference is 2. If you still roll something like a 5-3, I'm going to say again, the difference is 2. If someone argues and says, well, if the difference is 2 here, then the difference is -2 here, then I'm just going to say, fine, put an absolute value around it and throw away the negative. So the difference is 2 here and the difference is 2 here. Okay, so it was worded a little bit weirdly, I understand. But all I'm trying to say is that the numbers on the die are 2 apart, and I don't care which one is bigger, which one is smaller. All right, so if we understand that, then let's go ahead and list these. Let's see. So my thought process here is that I'm gonna, okay, so first I'm gonna write D, obviously, in curly brackets. And I'm gonna think, are there any outcomes where the first thing is a 1? Well, if this is a 1, the other one's gotta be a 3. So the difference is 2. Are there any outcomes where the first number is 2? Okay, 2, 4, obviously. But then when I put a 3 here, we got a couple options. It could be 3, 1, where the difference is 2, where they're 2 apart, or 3, 5, that also is 2 apart. Okay, what else? 4, if you do a 4, you can do a 4, 2, or a 4, 6. Those are both 2 apart. I'm running out of room, let's go to the next line. If I start the die with a 5, it could be a 5, 3. Can't go higher because it would be 5, 7, and there's no 7 on the die. And then 6, if it starts with a 6, it's 6, 4. There's no other one because you would go to 6, 8. Again, there's no 8 on the die. So that's what we have for D. And again, if that's confusing, it'd be best if you can just come up with it just like that. But if not, you can go back and look at the sample space and one by one, find the ones where the difference between the numbers is 2. And you'll see that those are all of them. Okay, then I want to find the probability of D. And as usual, absolute value of D over absolute value of S. Absolute value of D is 8. Absolute value of S is 36. Yeah, that's how D goes. Okay, let's go to the next one. Okay, E says you roll doubles. When you roll doubles, it's kind of like in the game of Monopoly or something where it means both numbers. So you're rolling a pair of dice, and both of the numbers are the same. Something like 6, 6, 3, 3. So that one shouldn't be so hard. To find E, I'm going to list them all. So here's a double. So you roll a 1, 1, or a 2, 2, or a 3, 3, or a 4, 4, or 5, 5, or 6, 6. Okay, and then probability of E is absolute value of E over absolute value of S. And there's 6 things in E, 36 things in S. Okay, let's try the next one. F is the event that the first die lands on 5. Okay, F for 5 it looks like. So F, you have to list all the outcomes where the first die lands on 5. So I guess it's 5, 1, 5, 2. Any outcome where the first one lands on 5. So they don't mention anything about the second one, so the second one can be anything. So let's keep going. 5, 3, 5, 4, 5, anything. So it looks like those are all the outcomes there. Okay, then ask for probability of F. Again, formula, absolute value of F over absolute value of S. And again, if you look up there and count, it looks like we have 6 things again, 36 total. Okay, let's try the next one. All right, it says the first die lands on an even number and the second die lands on an odd number. Okay, let's see if we can list all those. The first is even, the second is odd. Okay, so first is even, second is odd. There's one way. And since I realized 2 is even, I'm going to write all the ones that start with a 2 first. Try to get organized about it. You don't have to do it this way, but make sure no matter what you do, you come up with all of the outcomes. So let's see, 2, 1, 2, 3, 2, 5 are all the ones that start with a 2. Okay, and the first one's even, second one's odd. Okay, then I guess if it's not going to start with a 2 and it starts with an even, then it's going to have to start with 4. So we have 4, 1, 4, 3, 4, 5. And then the ones that start with a 6, I suppose, 6, 1, 6, 3, 6, 5. And that is the end of the story there. Those are all the outcomes where the first one lands on even, second one lands on odd. All right, and let's find the probability of that. It's absolute value of G over absolute value of S. If you count how many things are in G, it looks like 9 for this one, and 36 total.
yeah, that's how that goes. Okay, guys, I hope this helped. I hope the examples are a little more clear. But keep practicing. Again, do the supplemental homework. Make sure you're able to do all the problems. And guys, please let me know if you enjoy videos like this, if you feel like you were able to learn from them. And that way, if things get a little complicated in the future and I need to spend more time on a certain thing, I can continue making videos like this. All right, guys, that's it. Study hard, and I'll see you next class.